For nearly 6 decades, the way we physically interact with a computer has been defined by what Doug Engelbart demonstrated in 1968. You grip a mouse, you point at a pixel, and you click. Generative AI tools have existed mostly as smart advisors trapped inside text boxes. You ask a question, the model generates a response, and then you, the human, manually execute the next steps. This new model of agentic AI crosses the boundary into direct execution. Instead of offering advice, the system takes physical control, independently clicking buttons and typing data. Building custom APIs for legacy systems is often impractical. Instead, the user interface serves as the integration layer. But granting a probabilistic model the power to move your cursor creates a high-stakes trade-off. A hallucination in a chatbot is bad advice. A hallucination in an agent can lead to irreversible errors on live systems. Computer using AI is arriving through 3 distinct architectural strategies, each designed for a different type of access. Google is weaving these capabilities directly into the Chrome browser and its own hardware. Anthropic is providing a raw takeover of the entire desktop environment. And Microsoft is positioning screen acting agents as a highly governed extension of enterprise automation. Your choice between these 3 pathways depends on your specific workflow bottlenecks and your tolerance for security risks. Deploying the wrong architecture can lead to significant data leaks or broken production workflows. Google is deploying its magic pointer feature through Chrome and dedicated hardware like the Googlebook. Users interact using didactic voice commands. You point at an element on the screen and say, "Fix this," or "Compare these," and Gemini identifies the visual context around your cursor. This approach prioritizes a frictionless flow state. It removes the need to constantly copy data from your workspace and paste it into a separate AI window. Maintaining that context requires a continuous data loop. To keep the agent ready, the system relies on passive screen capture and an always-on microphone feeding directly into cloud processing. The magic pointer offers significant contextual speed, but users must accept continuous information exposure to get it. Anthropic's approach grants Claude unsandboxed control over the macOS desktop and local file systems. This enables Claude to operate almost any software, internal dashboard, or local document exactly like a human would, bypassing the need for official software integrations. However, screen-based control is slow. Taking continuous screenshots to interpret the desktop state creates significant latency compared to a direct machine-to-machine connection. It is also fragile. Complex multi-step tasks can fail if the screen state changes unexpectedly, creating a risk that the AI could alter or delete files if left unsupervised. While Claude is a striking research preview, its unsandboxed nature makes it unpredictable for mission-critical autonomous tasks today. Microsoft Copilot Studio targets enterprise software, ERPs, and portals that lack modern, usable APIs. It acts as an action layer, using visual perception to turn these clunky graphical interfaces into functional automated systems. In a corporate environment, a hallucinated click can execute unauthorized financial transactions or corrupt a master database. Microsoft manages this risk by enforcing human-in-the-loop gates. The system pauses low-confidence or high-risk actions until a human reviewer provides explicit approval. This introduces a specific type of maintenance debt. Because the agent relies on visual coordinates, a minor update that moves a button on a vendor portal can instantly break your automation pipeline. Copilot Studio can keep legacy applications functional, but it shifts the IT burden from building APIs to maintaining fragile user interface automations. All 3 of these systems share a common limitation in how they interact with software. Screen automation is a temporary bridge, not a permanent architectural solution. You save time by skipping formal integration today, but you generate long-term costs in error correction, latency, and continuous security oversight. These agents provide the most value when they are treated as systems requiring managed autonomy rather than set-and-forget tools. Choosing the right agent depends strictly on your primary daily bottleneck. If you need to increase your personal workflow speed and are comfortable with deep ecosystem lock-in, use Google's Magic Pointer for frictionless browser-level actions. If your focus is legacy system integration for a business, deploy Microsoft Copilot Studio, but mandate human review gates for all production workflows. If you are experimenting with broad task automation, utilize Anthropic's Claude, but limit its use to non-sensitive data while it remains in the research phase. Success in this era of computing depends on how strictly you govern what the AI is allowed to do.